So, hi, you said your name's Lakai?
Yes, sir.
All right, I'd like to thank you for doing this interview, man. I really appreciate it. On a scale of 1 to 10, how open-minded would you say you are?
10.
A 10? All right, cool. Do you think you should look at both sides of an argument before you make a decision on something?
That's fixing your train of thought. Yeah.
Yeah, so you think you should look at both sides of the argument?
Yes, sir.
What are you studying? What are you studying here at Wayne State?
Protesting rights of civilians.
That's the study actually here?
Civil acts.
All right, cool. Do you trust your senses? Like putting on your clothes, crossing the street, daily senses like that?
Yes, sir.
All right, cool. You trust the government?
Yes, sir.
You do? All right. How do you think everything came to be? Do you believe in like the Big Bang, creationism, or you don't have a belief on it?
Personally, the earth and the world came together and became flesh.
In flesh?
Yes,
So you
sir.
think like Big Bang, creationism, or you just
Yes,
don't?
sir.
That's just kind of how you believe it came together?
Yes, sir.
All right. What would be your definition of science?
Definitions of science.
Yeah.
Definitions of science. It's for the law. It's like population control.
Science?
Yes.
Would you agree with like the core of science? It should be like observable, measurable, testable, repeatable. That's like the core of it, I suppose.
All facts.
Yeah. All right. You think the majority's always right?
Of course.
Of course, the majority is always right.
Yes, sir.
All right. Do you think science should ever be a closed book?
No.
No. All right. To you, what's the difference between a belief and a knowing?
A lie. And it's basically a lie. It's a lie.
All right. Would you say like I like to give an example? A knowing would be there's two people here having a conversation right now. That'd be a knowing. That's
Yeah,
absolutely we know
yeah,
that. That's a
yeah,
fact, 100%.
yeah.
All right. This is kind of where the subject goes off, and like I said, most people don't agree with it, but it's picking up steam, and I think the media and stuff tries to push it down. But I'm just gonna ask you right off, man. What shape do you think the Earth is? Do you believe it's flat? Do you believe it's an oblate spheroid like you've always been taught, or do you believe it's without form or some other shape?
It's formally a spear, first and foremost, oval type situation. But other than that, the overall result is impossible because you don't see the moon or the sun coming together. So
Do you believe?
no flat, no square.
So you believe it's a oblate spheroid that rotates once a day and goes around the sun, pretty much?
Pretty much. Because if you got a core in the middle of the earth and then you got crossroads, come on,
Yeah. So
you got to drill that in. It's either the oval size spirit. That's all.
that's it. All right. You think that's a belief or a knowing?
It's annoying because the only reason it's called being called a spirit because it moves, it travels.
All right. You know anything about like fluid dynamics, how liquids behave, like in our reality, like how water behaves? Would you agree with me like this? It's a 1,000,000% fact that any liquid will take the shape of its container and then level out. In our reality, that's how water behaves.
Say that again.
Any liquid like water will take the shape of its container and level out 1,000,000% of the time. Put it in a cup, put it in a bath, put it in a pool, in a lake. Does water always take the shape of its container?
Pretty much. It's like clear evidence.
Yeah. All right. So they tell us the Earth's covered in over 72% water, and if water always takes the shape of its container and levels out, how could it be a sphere?
Because we can't see the earth move, so to us it's a spirit.
The
But
sphere.
because we make the world turn, but if we didn't, if we weren't on the earth, right? It wouldn't be a spirit no more.
If we weren't on it? All right. It's fair, I guess. But you'd agree, though, to believe in a globular Earth, water's bending around the sphere, though, like holding form.
Formally, you don't see, like I said, you don't see sharks just laying around, driving around and shit. Sorry for the.
It's cool. I don't mind.
But normally, see, water typically, it goes up and down, side to side.
Typically goes on. All right.
Yeah, you only can go on one.
But you agree?
direction.
You agree with nowhere in reality, in our reality, water doesn't ever conform to the exterior of a shape, though. In our reality, at least. No. So you'd have to me, that's how I was talking about science should be observable, measurable, testable, and repeatable. They can't show us water conforming to the exterior of a shape, so I have to take a leap of faith that that's what it's doing, pretty much. You know.
Exactly, from what's in the water, from the organisms what's in the water. Like, these one of these things like you got to look at it like if a shark can come up off the water, and go back down in the water, but we stay up on the earth, and we go down there, we can't stay down there.
All right. Well,
right, it's backwards. Like, you know what I'm saying? Like, you know how bubbles be forming up in the water, and then you know how you got bubbles in the air, like you blow bubbles.
Mm-hmm.
See how that work?
I see what you're saying. Yeah.
Right.
All right.
Water. See, organisms in water control air by water. We control water by air.
Oh, you already did? Okay, thank you so much.
Yeah, I can say.
All right, well, I will see you in class.
Do you know, in your opinion, do you think we breathe the same stuff in space? Like if you're next to the International Space Station, do you think they're breathing what we're breathing now?
Say it again.
You think we breathe the same thing in space? You think space is like what we're breathing in right now? If you're in outer space with no suit on or nothing, do you think it's like exactly what it is here or no?
It can't be because nothing up there defines it means but us.
Yeah.
Yeah.
So basically, they tell us space is a vacuum. It's like not a perfect vacuum. It's as close as you can get. And like I said, I like to go to natural science, and natural science tells me water can't conform to the exterior of shape. So they're telling us our atmosphere is adjacent to the vacuum of space without like a solid barrier, and nowhere in natural reality they can't show me that. Would you be able to give me an example of two opposing pressure systems existing side by side without a solid barrier? Like, have you ever used a pressurized deodorant canister before? You know what happens when you puncture that? The air comes out. So that's like another fact of science that they can't show us. They can't show us water conforming to the exterior shape, and they can't show us how our atmosphere is adjacent to vacuum space without a barrier. You ever thought about that before?
I feel like, you know what I'm saying? It's one of those things like, it's hard to explain. It's like one of them things like,
Gravity, basically.
It is gravity, but it's what comes with it. It's the components that come with it. Like, say if you build a building, right, and that building don't stop you from breathing. It just stop you from your destination. And just like it's a bunch of debris just laying around, but we breathe it in, but it don't stop us from moving. So that's what vacuums are.
All right.
It's the exact opposite of what defines and means of gravity. It's actually problem solving when you do that. When you talk about vacuum.
All right. You know the difference between like solar eclipse and lunar eclipse and all that? You know what they are? Or you want me to go over them real quick?
I'm gonna tell you this. Say if the sun was to come, that's the power of the blue moon. Say if the moon was to come closer, that's the power of the red moon. See, see you gotta think, right? Both the systems of the world play a big part.
All right.
In all matter. So yeah.
All right. Well, how about, what they tell us, like a solar eclipse, though, is basically the moon goes in front of the sun. Have you ever watched one before when the sun gets blocked out by the moon? That's a solar eclipse. And then a lunar eclipse, could you hold both your hands out like this for me? Let's say the Earth's in between your hands, right here. What you believe basically is the sun's on one side, the Earth's in the middle, and the moon's on the other side. You believe it's the sun casting the Earth's shadow on the moon, and it's always a curved surface. That's what the lunar eclipse is, and it's always dark on that side. In this theory here, would you agree the sun's round? From our perspective, at least looking at it? If you just look at it, I mean, I think it's round.
The sun is not really round.
If you look at it, does it look circular at least?
The sun, yeah, it's circle. You know why? Because it's a mirror reflection of our people.
All right. Well, here in this theory here, basically, you can hold your hands out again for me real quick. This theory here, it's stating that basically the sun's on the other side. There's nothing in between the earth, the sun and the moon, and it's actually the sun's shadow casting that round shadow on the earth, or on the moon. Sorry. You think you'd be able to disprove that, or no?
I could say I could finish what I was saying by that goes along with what you were saying about the sun being round. It's actually what everybody been wondering, like when do space end? It ends right there. Anything further past that?
That's fair, man. All right. Well, here I'm going to give you a couple examples. These are proofs of what
it's the power of the moon. Well,
right.
Power of the sun that gives the sun. The power of the sun that gives the moon, and the power of the moon that gives the sun.
All right. Well, I'll give you. Here's the main thing. What I go off of to like counter basically what they give proof of. It's like gravity and they're spinning and stuff. All right. Have you ever heard of the North Star before?
Yes, sir.
It's Polaris. So we can agree it's like directly above the North Pole. It's the only stationary star up there, and it vibrates a little bit. And it's the fact you can look at it, and every star does like the perfect geocentric circle around it. So how would you be able to disprove that everything's actually spinning around us, causing the Coriolis effect? The moon would push the tides, the sun would contract the tides. They say if you shoot a long-range shot west when the sun's there, it's going to dip down because of the Coriolis effect. I say that's based off a false axiom, and if you shoot a bullet west at nighttime when the moon's there, it's going to bounce up, and I think that lunar eclipse is the sun blocking out the moon. So to prove me wrong, you'd have to basically give me an example of water conforming the exterior of a shape, or give me an example of a positive pressure system that's a negative pressure system with no solid barrier, or disprove that it's the sun blocking out the moon for a lunar eclipse. And I'll give you $100 if you can do that. You think you'd be able to?
Yeah.
How?
Vibrations and the different type of mode. You know what I'm saying? The vibrations and the different type of mode is in, like you know, how hard the frequency is, or how soft the frequency is.
That's how?
Yep.
All right. I mean, it's fair. I don't know if I'm gonna give you $100 for that, but I mean, it's an opinion at least. Hey, I appreciate it.
Thank you, sir.
But all right, man. I mean, that's pretty much the interview. Whatever. I appreciate it. Thanks a lot, man. You're a great interview. Thanks.